When is stuff going to get posted?
What stuff?
To YouTube, the videos.
Oh, I'm going to do it today. Did I not post some of the videos? Is that the problem?
I think so.
Okay. Oh, also, in the formula sheet, I totally mixed it up. I wasn't supposed to write Q. I was supposed to write 1 minus P, and Q hat is 1 minus P hat. I'll change those for you for the formula sheet. And also, E stands for margin of error. That's what E stands for. Okay.
What is Q?
Q is 1 minus P. And then Q hat is 1 minus P hat. Okay, also, here are the two pages that I'm talking about. It's this one here and this one here. This will be in the video that's being posted today, so you'll be able to see these. Okay, now let's go over the mock test. Any other questions? Sounds like you guys have some questions. Okay, luckily it was recording my laptop, so that'll still be in the video. It just didn't go onto the screen right now.
Oh, but yeah, the last video was from the 11th.
Okay, yeah, so I need to do some uploading. Okay, so one last time, it's this page and this page that you can use on the test. Yes.
We use the ones we already marked up with notes. If you just look at them before the test.
If you Xerox, I know nobody uses the word Xerox anymore. If you take a copy of the front page, making sure there's no back, you're good. Or if I may accept Anna's proposal where you glue them together so you can't see the inside. Okay, doing a 95% confidence interval, we have to make sure that we look at the formula sheet for this on the confidence interval formulas. So if we take a look at the formula sheet, where is the formula sheet? Here's the formula sheet. We have to know which formula to use. Here we go, test 2 formula sheet. Okay, which of these formulas is used for confidence intervals and which of these are used for hypothesis testing?
Confidence intervals.
Good. So the first 3 that have an E in front of them, what does E stand for? Margin of error. Confidence intervals have a margin of error. So now we have to know which one are we using for the first question on the mock test. This one here, because you only have, chances are you're probably going to be using this one. Very rarely do you use this one here. In fact, next to this one, say unlikely to be on the test.
What about the top one?
No, we want to do a t-test because we want to use the sample standard deviation.
What about the top formula?
Yeah, this one is likely because you're going to be having a p-hat most likely. It's this one. This is the unlikely one. Everyone write unlikely next to that one. Just this one. Okay, so we're going to use this one here, meaning we need S. Do we know what the difference between S and sigma is? Good. These values here, is this the sample or the population? Sample, so that's why we're using that formula. Okay, so I'm going to zoom in, and I have to find the mean and standard deviation equals average, highlight the values, 318.6, standard deviation STDEV.S, highlight the values, 30.53. So I'm going to write those down. So we have X bar is equal to 318.6, S equals 30.529. Now I'm going to find the margin of error using the formula, which is E equals Z alpha over 2. So we have to do the Z alpha over 2 value. Sorry, the T alpha over 2 value. We have 95% in the middle. And what do we have on the sides? 0.25. So I have 0.25 over here, and I have 0.025 over here. Now, I look at the formula, and it says T alpha over 2. So am I going to do T or norm.S? T. So you have to do T. So T dot, anytime you go from area to t-value, it's dot INV, and then you're going to put in what value? Good, 0, 2, 5. Degrees of freedom, we have 10 values, so that means degrees of freedom is 9. Because if we look at the formula sheet, we're using this formula here, which has...
No, but like, how did you know to use that formula? Like, what problem? What?
Oh, this here, S. How do we find S again? It's STDEV dot S of the sample values. Okay. Does that answer the question? It's very rare that you would use norm.s because you're not going to be given this value. You have to be given this value from the population. We don't have the population. Okay, when you do that, you end up with negative 2.26. So our margin of error is, so you get negative 2.26. So our margin of error is 2.26 times 30.529 divided by the square root of the sample size, which is 10. Exactly. Or you could do t.inv of 0.975, and that would give you the positive 2. But yeah, you just jump to the... Okay, the margin of error, when you do that, when you do the third, so you want to take this standard deviation divided by SQRT of 10 and then multiply it by the t value, which is 2.26. You end up with 21.82. It's this over here. 21.82. Okay, how do we now find the upper and lower bound? What do we do with that? Good. So I'm going to do 318.6 plus 21.82 and then 318.6 minus 21.82. I only care about the rounding at the end.
So we don't round it.
I wouldn't round it until the end.
Okay, but you round it.
I rounded it just so that I could write it on the screen. I'm going to be more concerned about what are the final answers. Okay, questions on number 1. So there's a 95% chance that the mean is between those two values, the 340.44 and 296.76. Yeah, but I realize now that your homework didn't really make you write that, right? So if you phrase your answers similar to the homework, it gets credit. But that's one acceptable. Make sure the most important part is getting the lower and the upper bound of the numbers. The only time we can use norm.s is when you have the population standard deviation. Do we have the population? No. Can we find the standard deviation of the population if we don't have the population? How do you find the standard deviation of the population? You need the population. Do we have a population?
No.
No, we have a sample, so we have to use T. Yes.
Do you have a copy when you come?
Another mock test?
Yeah.
No, I
Can you
don't.
upload it?
I'll upload it to Connect Math. I'll just send it in the email that I'm planning to send everyone today. Okay, any more questions on number 1? You're going to be using T. Use T for these problems. Okay, next, hypothesis test. I see greater than 300, so I want mean is greater than 300. And then that means this is mean equals 300. Next, I want to find the t value, which is x bar minus mean s divided by the square root of n. Which formula is this? It's this one. This one is also gonna be unlikely that you'll use this on a hypothesis testing problem. You're most likely gonna be using this. Why is it unlikely to use this one?
We're not gonna be doing the population.
Yeah, we're not gonna be given the population. The only problems where you may use this one is like in questions 4 and 5, where you're given population information, but those are completely different problems. Those, you don't even really have to use this formula because I'm gonna show you a shortcut to do it. The shortcuts, you don't have to worry about this formula, so you don't mix them up. I don't want us to mix the formulas.
What do you use, the circle for hypothesis or about the?
This is for a hypothesis testing about the proportion, so that's question 3 that we're gonna do. Okay, so back to the mock test, when I plug the values in, the sample mean is 318.6. Do you guys remember how I got that? Okay, 300, S is 30.529 to the square root of 10. And when you plug all that into the values, you get 1.93. Now we have to see whether this is an extreme value, so we have to find where the extreme values are. What side are the extreme values on if it's a right-tailed test? Right side. The extreme values are over here. We're doing critical value approach, so that means we need the critical value for the right-tailed test. What number am I going to put into Excel? If I put 0.01, it's actually going to give me the t-value on this side. So what's 1 minus 0.01? 0.99. Okay, any questions so far on how I got any of this? This page, that's why I'm letting you use these 2 pages, because you can see when it's a right-tailed test, the extreme values go on this side. When it's left-tailed, that's when you put it on this side, and when it's two-tailed, you split it in half. You have half on both. Okay, when I do this, I'm gonna do t, again, t.inv of 0.99, comma 9, which is degrees of freedom, and that gives me 2.82. So that means extreme values are 2.82 and higher. And what was our value? Are we in extreme value? If extreme values have to be 2.82 or higher? No. Okay. So we got we're using critical value approach. So the critical value tells us that t-values that are 2.82 and higher are considered extreme values, but our t-value was 1.93. Failed to reject.
I have a slight question that doesn't really have to do with that.
Yes.
But also it has to do with the critical value. Why are you doing 0.999? Because in here when you do for 0.01, you just do 0.99 and then you do the
Because I think when I did it on there, I did it for the norm.s.
Oh, that's why. Okay.
Plus, it's going to be different for every degree of freedom.
It's the same degree of freedom.
Oh, it is. Exactly. You would have to be higher than 2.82 to reject. This is not an extreme value. It helps to write whether this is extreme or not. So not extreme. So fail to reject. If this was a left-tailed test, you would have gotten negative 2.82. So that means anything below negative 2.82 would be considered an extreme value. And once again, 1.93 is not below negative 2. You would still fail to reject.
We're not tested on like in between, right?
That'd be if it's a two-tailed test, then it has to be on either side. If it falls in between, it gets failed to reject. Yes. That's a critical value for this. Let me label that actually. So no. The data does not.
The z-value is the test.
Yeah. Are you talking about the t-value? Because there's two t-values. There's the critical value, and then there's also the 1.93. That's called the test stat. So this is a not extreme test stat. Yeah, so then you split the 0. So they would have been the ones from this problem. So you split it in half, and then you do t that way. Actually, you would have, because we were doing 0.01 significance, you would have 0.005 on both sides. Because you don't split this in half, you split this in half. Okay. You split the 0.01 in half. Do you want me to do that real quick?
Or you can do it in the review session.
Okay, I'll do it in the review session just because we are low time. Okay, any other questions on number 2? Okay, next, we're gonna do a proportion. We're deciding whether people believe in paying sales tax. I probably would say no. That's why only 437 said yes out of 10, 15, because who wants to pay sales tax? I mean, a lot of us kind of get away with not paying sales tax. That's why on Amazon.com, if you order it and it's out of state, you don't pay sales tax. But these people believe that you should pay sales tax. Those 437 people. So that's your p hat is the 437 out of the 1,015. When you do that, you get 0.43. Now, we want to know whether there's convincing evidence that the favor of tax varies from 0.05. So how would we make a hypothesis test? Well, let's use P because we're dealing with the... Good. We said varies. That means differs or not equal to 0.45. Good. Next, we have to know which formula to use. Which formula has the proportion in it? This one. So that's the formula with the proportion. So that's how we know to use that formula. So mainly for the hypothesis testing, you're mainly going to use this formula and this formula. And for the confidence intervals, you're mainly going to, I don't want to jump again because then you're going to make it more generic. Yes. This one.
Have you shown us been working on the video?
I have.
Okay, so you can remember.
Okay, for confidence intervals, you're mostly going to use this one and this one. How do we know whether to use this one or this one?
Depending on if it's, population. No, you use that
If it's
one.
p hat.
Good. This is proportion. This one is mean. And then same thing with this one here and this one here. This one is the mean, and that one's the proportion. Okay, so back to this one here. I want to find the z value, which is p hat minus p over p times 1 minus p over n. And then when you plug that in, you get 0.43 minus 0.45. Square root of 0.45 times 0.55. What's our n? How many people went into the sample? Good, 1,015. When you do all of that, you end up with negative 1.24. Now this is p-value approach, so you need to put the negative 1.24 on the graph. And because it's a p-value, if we look at p-value approach, here's p-value approach. What side are the extreme values on? Good, above and below. So if your test stat was -2, you need the opposite side above +2. So our test stat was not -2, it was negative 1.24. So what's missing from the graph? Positive 1.24. So you need to put the positive 1.24 on the graph, and I'm going to shade middle or sides? Sides. Okay. Do I need to really find both of these, or can I just take one of them and double it? One and double. Which one's the easy one? No, the negative one, you just do norm.s.dist.
So why do you do norm dot s dot not
Because that's a good question. So if we go to the formula, if we look at the formula sheet, there's a z here. It's not a t, it's a z. Yeah, so for formulas, which one of these use norm.s? Formula 1 and formula 3. So norm.s is formula 1 and formula 3. Technically formula 2 and formula 5, but we're not going to really be dealing with these formulas. So you can use norm.s as well. The ones that use t are formulas 3 and formula 6. So formulas 3 and formula 6 use the t instead of the norm.s.
So if anything is a z, you use norm.s.
Exactly, and if it's a t, you do t.
We're doing,
And why are we using dot this?
Oh, because when you do inverse, you're given the area. Were we given the area in this problem? No, so we want to do dist. When you're given the area, that's when you do INV. When you're given the t value.
Wait.
Yeah, Michaela? Or yeah?
Sorry, the formulas 4 and 5, C and the S and the N. Or the S line.
Anything with a z in it, you use norm.s. Anything with a t in it, you use t.
Which one the S though? This during.
Oh, for formulas, you know, it depends on whether you're using the critical value approach or if you're using the p-value approach. When you do the p-value approach, you'd use dist. It depends on what the picture looks like. I highly recommend drawing pictures. Okay, one last time, how do we know whether to use dist or to use INV? Dist is when you're given a z or a t value.
If it's when you're given an area.
Good. INV is when you're given an area. Good. Dist is for when you're given the t or the z, and INV is for areas only. Just think INV area. What's some acronym that we or something that can help us?
When you say we're given the area, does that mean that we're given like 6, 7.5 to
No, it'd be like a percentage. Like a significance level or a
okay.
or a
But we're given
hypothesis.
the significance value in the third one too.
Yeah. But because it's p-value approach, we don't calculate the critical value.
So what do we do with that significance level?
We compare it to the p-value. So we're going to calculate the p-value now. Let's calculate the p-value. I'm going to do norm.s.dist of what value? I'm going to do negative 1.24, comma true. Norm, and when you do that, I actually did that already. It's 0.106. So the p-value is 0.106 times 2, or 0.213. Does that indicate extreme or not? What's the significance level? Is 2, which is 2%. So only 2% of values are considered extreme. So the top 2% are extreme. So if your p-value is 21.3%, is that extreme if only the top 2% are extreme? No. This is not an extreme p-value. Okay.
So p-value is bigger than the significance level of situation.
Exactly. Fail to reject.
So it's not in your top 2%. If it was like, because if it was like 1%, then no extreme, that's, you know? Wouldn't that make sense? Like if If it's 1%, that would be considered extreme because it's, Less
Well,
than
you
10%.
20, this is in the top 21.3%, that's not extreme at all.
What if that equaled instead of 21%, if it equaled 1% instead, wouldn't that be considered extreme?
Oh, if this was 1%, yeah.
Wouldn't that be because it's greater, or because it's less than?
High p-values are not extreme, it's the low p-values that are extreme, when you're in the top like 1% or when you're in the top 0.5% or when you're in the top.
P-value is a percent.
Exactly, the p-value is a percentage, which is why you compare it to the significance level. So we're comparing, when you do critical value approach, you compare the p-values. When you do p-value approach, you compare the percentages. So,
So because it's greater, it's able to reject.
fail to reject, yes, because only the top, yes.
So this might be so dumb, but when we're writing like our final answer to a question like this, is fail to reject the final answer, or do we?
You'll have way more room on the actual test. You want to say fail to reject, and then the problem says, is there enough evidence to, there's not enough evidence. Not enough evidence. I'm kind of skipping the explanations due to time. Yeah, because I still want to do 4 and 5. Those won't take very long. Okay, any more questions on how do we know? Okay, with the p-value approach, what are we comparing? Percentages such as the significance level and the p-value. Let's maybe summarize this. So p-value approach, you compare percentages, which is the p-value and significance level. And then the critical value approach, you are comparing what values? Does anyone remember? Compare the t values, or sometimes z values. So that's going to be the critical value and test stat. Okay, any questions on p-value approach versus critical value approach? Critical value approach, you know you're comparing the critical value. P-value approach, you know you're comparing the p-value. Ask yourself, what is a critical value? It's a t-value, so you have to compare it to the test stat, because that's another t-value. With the p-value approach, you have a percentage, which is the p-value, so you have to compare it to the significance level. Okay, any last questions on this? These are more important than questions 4 and 5, because there may only be one question from questions 4 and 5, but there's going to be 5. Yeah, we're still going to do them. Okay, let's do them real quick. Okay, would it be unusual for the mean weight of writers to be above the recommended limit? What's the recommended limit? 200, so we have 200 here, and the mean is 194. So above means above, so you're going to do norm. Well, first of all, we want the right area, so it's 1 minus norm dot dist of 200, and you put the mean in, which is 200, comma, 194. Okay, now the standard deviation is 68, but you have to do the standard deviation for the mean, so what does that mean? 68 divided by 60, just the sample size. Is that not a square root of 60?
Yeah, you just said 60 out loud.
Oh, sorry, my bad. When you do that, it's 0.247. Okay, then the last one is basically the same thing, but again, the limit is 200, but you're saying the individual weight is 200. So again, it's still the right area norm dot dist, but what's the only thing that's different? Are you going to divide the standard deviation by the square root of 60? No, because it's the individual, it's not the mean. Comment true. Because if you did norm.sdist, you have to turn it into a z-value, and for time saving, Plus then we have to use the formula that I said we're not gonna use that much. High, confidence intervals use inverse and critical value approach uses inverse. When you do this, you get 0.465. Unusual would be usually 10% or less, so then neither of these are really unusual. But this is less likely to happen than this one. This one is 4 to 7%. This one is 5%. I mean, it really depends on your significance level. If you don't have a significance level, it's up to you.
When do you use?
No, neither of these are unusual because this is a really high chance. This is a 25% chance. That's 1 in every 4 roller coaster rides. There's going to be a problem. And this is 47% chance. Yes, or yes, Alina?
When do you use T-dots? So these are the main formulas we're using, norm, or
T dot dist and T dot.
those are the most likely to be on there.
Yes.
Okay, so I just wanted to make sure, because I don't really know what to use T-dots.
It's if you're doing a hypothesis test and you want to do p-value approach. Don't forget about the review session.
What room are you in?
217
Library?
library.